So this is more than you ever wanted to know about rope. Rope historically was made out of natural plant fibers, things like flax or sisal or manila, hardy fibers that could be twisted together to form a yarn, much the same way as you would spin wool to make knitting yarn. In this case it's twisted together, and when I untwist it you can see it opens up and you can see the individual fibers there. So these fibers are twisted together and joined together in a long string, and once that's been done, individual bundles of fibers are twisted together to form individual strands of rope, and this rope is made up of 3 strands of fibers that in themselves are made up of 3 strands. So when I open up this rope by twisting it against the way it was twisted, you can see it opens up the same way. So it's just a building up of thickness. This plating or twisting allows the rope to be flexible and yet very strong. Rope can be made up of any kind of fibrous material or any kind of long strand. First Nations used everything from spruce roots and cedar bark to leather as rope twisted together. And there's a great video that I've posted online of master rope makers in Chatham in the UK, where they show the historical manufacture of rope. They've made rope in the same factory for the last 400 years. In order to stop the rope from unraveling at the ends, we have to wrap around with a waxed cord tightly around the end of it, and that stops the rope from unraveling. This kind of natural fiber rope is prone to mildew and rot. If it's kept wet, it will gradually weaken, and the fibers are relatively abrasive. But for hundreds of years it was the only option. It really was only until the 1950s that synthetic ropes became available, and ropes like polyester braided rope became more common. This is a polypropylene rope. It's very inexpensive, but it's made exactly the same way as the other rope, the natural fiber rope. It's 3 strands of material that in themselves are made out of individual fibers that are twisted together. So together it becomes a very flexible material. The advantage of polypropylene is that it floats in water, and but it has a disadvantage in that it breaks down with ultraviolet light. So when it's exposed outdoors for a couple of years, it weakens and will eventually break. This is a polypropylene rope. It's very inexpensive, but it's made exactly the same way as the other rope, the natural fiber rope. It's 3 strands of material that in themselves are made out of individual fibers that are twisted together. So together it becomes a very flexible material. The advantage of polypropylene is that it won't. The advantage of polypropylene is that it floats in water, and but it has a disadvantage in that it breaks down with ultraviolet light. So when it's exposed outdoors for a couple of years, it weakens and will eventually break. This rope here is also made out of polypropylene, has the same kind of properties as the twisted rope, except that it's braided in that rather than simply twisting the fibers, they are braided the same way as you'd do a hair braid, and so it forms a hollow core. And the advantage of this is you can tie it into tighter knots, and it's just much more flexible than the simple twisted rope. Rope comes in all kinds of diameters. Obviously, this is a much thinner rope, typically called cordage. This is made out of polyester. The only difference between these two is that one is a smaller diameter. They're both made the same way, where we have an internal core of polyester fibers that are then covered with a braided exterior core. Polyester has the advantage of having limited stretch, so it's really good for industrial applications and climbing. It doesn't lose any of its strength when it's wet, unlike the sisal rope, which tends to break down when it's wet. This rope here is made out of nylon, and like the polyester rope here, it has a braided exterior core, and rather than having single fibers on the inside of the core, it actually is made up of a braided core inside an exterior braided core. And so this makes it extremely flexible and very easy to tie into tight knots. Nylon rope has a little bit of stretch, so it's good for applications where you need a little bit of shock absorbency, things like mooring lines or fall arresting in safety equipment. Nylon rope loses some of its strength in water, so it's less appropriate than a polypropylene rope. It's also a lot more expensive, but it's a lot stronger than a polypropylene rope. The ends of synthetic ropes can be melted to seal the ends to stop them from unraveling. Often they're cut with a heat cutter, which both cuts and seals the end of the rope at the same time. So unlike the sisal rope, which has to be manually whipped to seal the end, that makes it very easy to finish off the end of a rope. This piece of metal here, screwed to this block of wood, is referred to as a cleat, and we can take rope and secure it on the cleat. This is very common in boats, but it can also be used for any kind of adjustable rope that might hold up a window blind or a hammock or anything like that. It's common simply to wrap the rope around the cleat, but that's not particularly positive, and the loose end can come undone. A better approach is to loop the rope over and under itself, crossing over, and then with the last pass looping the rope around and pulling it tight against the cleat, which forms a knot at this end and stops the rope from getting loose at the end where the tension is. It's then quite easy to loosen it off and remove the rope from the cleat when you want to undo it. Often it's necessary with rope to attach it to a stationary object like a post or pole, and it's a good idea when doing that to wrap it around the pole at least once in order to allow the friction of the wrapping of the rope around the pole to resist the temptation for the rope to slip. So if you're pulling against something, if you wrap it around a pole, you can easily pull that tighter and tighter without it slipping back on itself. You'll have the mechanical advantage of the wrapping. This is referred to as a round turn. If you want to secure the rope around the post, it's a simple matter of tying a half hitch, which is a very simple overhand knot, and then securing it with a second half hitch which is tied the same way. When those are pulled tight, we end up with a knot that won't slip, and the mechanical advantages of the round turn. Knots are really important when you're working with rope because they'll help you secure a load or tie a rope to itself or stop the rope from slipping. Some of the terminology we use when we're tying knots are the working end, which is the free end of the rope at the end that moves through the knot. We have a standing end, which is the length of rope that will be used to tie the knot. We have a bite, which is B-I-G-H-T, and that is just a bend in the rope. And that's different than a loop, which is where the rope actually crosses over itself. So this is a bend or a bite, and then the loop just wraps around itself. This is an overhand loop where the working end crosses over top of the rope, and an underhand loop is where the working end crosses underneath. Those are the main terms that we use when we're talking about knots. Most basic of all knots is an overhand knot, and that's where the working end crosses over and comes through a loop. And that's can be used as a stop knot to stop the rope from slipping through a feature. A simple overhand knot can be done with 2 ropes, and in fact if you tied your shoes today you did exactly that, where you fed one rope over the other and created an overhand knot, but just with 2 working ends. This basic overhand knot is the building block of all knots, and we can make it more secure obviously by doing another overhand knot, crossing the red rope over the white rope and pulling it together so that the ends of the rope exit the same side of the knot in each case. And this is referred to as a reef knot. That's a knot that is very secure and won't come undone under strain. The overhand knot can be used as a stopper knot when it's tied on the working end of the rope. You pull that down, tighten that up, and that's often used in sewing just to create an end knot when you're hand sewing on the end of a thread. An even stronger stopper knot is a figure-8 knot, where we create a loop and then another loop which forms a figure-8, and then feed the working end through the final last loop, and that gives a larger stopper knot area which will not come undone. Creating a loop in the end of a rope is pretty important to make sure that it doesn't slip. An easy way to do that is to create a bite and simply tie it around itself to pull that tight, and that will create a simple loop that you can throw over something that won't slip. The disadvantage of this type of loop knot is that the more strain that is put on it, the knot gets tighter and tighter and becomes very difficult to undo, especially if it's wet. Another type of loop you can tie in the end of rope that you do want to slip tight around something is tying a simple overhand knot with the working end around the standing end, pulling that tight, and then the loop itself will slide through with the knot and constrict around the object you put in the loop. To make a slip loop more secure, we can also tie the standard overhand knot and then a secondary stopper knot at the end of the rope, just in case this slips, it can't slide through the other loop. So this will allow us to securely constrict around a bundle of something that we're lifting. The best type of loop knot to put on the end of a rope is a bowline knot, and that is created by an overhand loop in the rope, and then we feed the working end through the hole or through the loop, around the standing end, and back through the loop. Pulling that tight will create a loop knot that is very secure, can't come undone, but when the tension is off it is very easy to untie. One way to remember how to tie a bowline knot is by creating that first loop. We say the rabbit is going down the hole, it's coming around the tree, and comes back out the hole again to create the knot. If you have a ring and want to secure it to a rope, it's a simple matter to take a bite of the rope or a loop and feed it through the ring, and then feed the ring through the loop, and that forms a neat little connection there. So that can happen anywhere along the length of a rope. For example, if you were needing to put a series of rings along a length of rope to hang a tarp or something like that when you're camping. If you want to secure a load and be able to tension it to give some mechanical advantage, you can use what's referred to as a trucker's hitch. And I use this often when I'm mounting tarps in camping, or securing a load on the roof racks of a car or something like that. You start by taking the length of rope that's secured at the far end against a stationary object, so it might be another tree or something like that, and you'll make a loop in the rope and pass it over itself, so you end up with a loop in the rope like that. Then you can take the working end of the rope and feed it through the other stationary object, which might be another tree. In this case, it's a ring that I've attached to a rope, and that's attached to a stationary object so it can't move. And I'll feed the working end through that ring, and I can pull on that, and if I can tie that if I'd like, but I don't end up with really any tension on that. So instead, having passed it through the ring, I'm going to take the end of the rope and pass a loop through the other loop, which then allows me to pull on that, almost using the two loops as pulleys to give some tension on that. So it gives me some mechanical advantage. I'm pulling on that, and I can then take the working end of the rope and pass it through the loop that I've just made and pull that tight. And if I do that 3 or 4 times, I'm creating a chain of loops that will resist the knot coming undone. So that now has some tension on the 2 points, and creates a very strong connection. The nice thing about this knot is, although it's very strong under tension, we can undo it simply by pulling the working end of the rope, and that releases it. If you want to secure the trucker's hitch so it can't come undone, you can take the working end of the rope, feed it through that final loop, and pull that tight. And that creates a knot at the very end that can't come loose even if you pull on the end of the rope. To undo it, we simply undo this last knot, pull the working end from the loop, and then we can release that knot. Closely related to rope are woven fiber straps. In this case, this is a material called Kevlar, which is extremely durable and strong material. This half-inch wide strap has an 1,800-pound breaking strength, and this is used to pull fiber optic cable through conduits and other really high-tech processes which require really strong material to avoid any kind of breakage. These are also woven polyester straps that are stitched together with a loop on the end, and they're designed for lifting heavy loads. They can be wrapped around an object to be able to lift the object. They can be looped through to surround an object and lift it up like a sling. And an even heavier version of the same kind of thing is this heavy-duty canvas strap, which has also two loops on the end, which can be used to wrap around a load or lift it directly. And the weight rating is on the plate here. This lists 3 different ways of lifting something, and the total strength that it can lift is 6,600 pounds when wrapped around an object and lifted by both ends. Flat woven material like this is often used in hold down straps that will secure cargo in transport, or band clamps, which we use often in the furniture studio. They would have one end that is connected to a ratchet mechanism, and the other is a free end that has a long length of strap attached to it with a hook on one end, and we can adjust the length of the strap quite easily by pulling it through the ratchet mechanism. The ratchet mechanism consists of a circular tumbler inside that the strap is fed through. When I move the lever, it moves the ratchet mechanism and the teeth engage, stopping the hook from loosening off, and as it gradually tensions around the spool, it gets tighter and tighter. When I want to loosen off the ratchet mechanism, I pull back the retaining clip off of the teeth of the ratchet mechanism and swing it fully around, which then pushes the other ratchet mechanism away, allowing me to loosen off the tension on the device. It's a little bit tricky to figure out, but after you do it a couple of times, it becomes pretty much second nature. Ratchet straps come in all kinds of different sizes. This is a slightly heavier duty version with a different type of handle, but similar kind of mechanism. This tool operates on a similar principle to the ratchet strap, although it's a lot more heavy duty. It has a steel hook on the end with a clip and a swivel. It has a spool with a ratchet mechanism that allows us to rotate it with a lever, and that will shorten the length of the steel cable that runs to the other end, where there's another hook in place that's connected to a pulley, which increases the mechanical advantage of the pulling device. So this is rated to pull 2 tons in a horizontal fashion. It's not designed for lifting. This single strand wire rope is made up of individual filaments of steel that are twisted together just like normal rope, but it's obviously a lot stronger. It's about a 1/16 of an inch in diameter, and we can untwist it so you can see that this has essentially the same structure as the rope we looked at earlier. If we unravel it, we can see that they're made up of individual filaments that are all twisted together to form one individual strand. This is about a 1/16 of an inch in diameter, and heavier wire ropes, which are used in industry and things like mining and forestry, would be made up of individual strands like this, bundled together and then twisted together in ever-increasing bundles to make ropes that are much thicker in diameter. This thin wire rope has a breaking strength of 480 pounds, which is pretty amazing when you consider how thin it is.
This chart shows the minimum breaking strength and a working load limit of a range of diameters of wire rope. Never exceed the working load limit, which is typically 1/3 the minimum breaking strength.
You have to cut wire rope with bypass cutters, which have hardened steel jaws that bypass each other. So we can set the wire rope in there and simply clip it cleanly. It's important that the end be very clean because we have fasteners that we use that we feed the wire rope through, and if it's frayed like this, it's really hard to get it through the little clips. Wire rope like this is often called aircraft cable because it was originally used to control the rudders and wing flaps of aircraft because it was so strong and reliable. We often use it to suspend objects, things like artwork and so on, from the ceiling by creating loops. And we can use small fasteners, which are extruded aluminum or sometimes copper sleeves, that the wire rope feeds through and then loops around and feeds through again. Once that loop is made, we can crimp this with a special tool, and that will hold that in place. The crimping tool has different sizes of openings for different sizes of wire rope. In this case, this is a small swaging tool, and the largest diameter wire rope it will swage is 1/16 of an inch in diameter, which is what we have here. The aluminum sleeve is fed over top of the wire rope, and you form a loop, and that is fed through again, and you adjust the size of a loop for what you want. You might want to even loop this around an object that you are hanging if there's a hook in it already, and you can draw that up tight against the whatever feature you're using to hang. The length of the wire rope that sticks out the end should be at least a couple of diameters length past the end of the sleeve. And then we take the sleeve and feed it into the correct size of the swaging tool opening. So the crimping tool or swaging tool fits over top of that, making sure that we've got enough length sticking out the end. I'm going to hold this close to the end of the length of the aluminum sleeve and squeeze this down to deform the aluminum around the galvanized wire. So this should be closed far enough that it completely deforms the aluminum, creating a locking sleeve. I've done one crimp here. I can crimp it again, leaving a little bit of space between the two crimps, and that will ensure that the sleeve is completely deformed around the loop. So that's a very strong connection. Different diameters of wire rope can be temporarily crimped by using a bolting crimp here, which consists of a U-shaped bolt and a cast piece of metal and a couple of nuts, and together it forms a unit that allows you to feed over top of the wire loop, close this up, and once the nuts are installed and tightened, it clamps the wire together so that the wire can't loosen off. That will be a temporary fixing. Typically you would put a pair of them in order to ensure that you've got the proper strength, and if need be you can remove them, loosen off the nuts, and change out the whatever fitting that might be going around. This wire rope is made out of galvanized steel, and typically you would use aluminum sleeves with galvanized steel. With a stainless steel cable, it's important to use copper sleeves because the aluminum sleeves used with stainless steel will eventually start to corrode. These come in various sizes and need to be purchased for the size of wire rope you're using. It's possible to purchase quick release fasteners that will allow you to attach lengths of wire rope into a ceiling or into another structural member, and this particular fitting has a spring-loaded mechanism that allows you to feed the wire rope through into the mechanism and it will not pull through. So we can adjust that mechanism by pushing it in and sliding the rope in or out to adjust its height, and it won't draw back. So if I want to hang something from the ceiling, I can bolt this into the ceiling and then feed the wire rope up into it to adjust the hanging height. When I get it to the correct height, I can lock it down by threading this adjustment in. That holds it in place and it won't move up or down. If at any point I want to adjust for height, perhaps I've got several points of contact and I want to level a structure hanging from the ceiling, I can loosen that off, and simply by depressing that I can adjust down or up to level my assembly, and then I can lock it into position. This part of it is threaded, so I can bolt it into the ceiling from above. And this is just one type of slip fastener like this. There are many other types available on the market.
Here's a close-up of the clutch mechanism that allows you to slip the aircraft cable through and change the length of the suspension. A little spring can be released, and then we can lock that knob down to restrain it from moving in or out.
Larger diameter rope obviously requires larger diameter sleeves. This one is designed for a 1/4 inch diameter wire rope, and this crimping tool is nowhere near large enough to crimp that size. So typically this is done with a much larger type of tool industrially. This 1/4 inch diameter wire rope has a loop on the end that's protected by a thimble, which protects it from abrasion. It's a much heavier duty crimp end on that, and it is crimped around a forged eye that can bolt onto a wood member. The other end of it is attached to a turnbuckle, which allows us to tighten and loosen the length of the cable. So this is used commonly in supporting structures where or railings and so on, where you want to be able to tighten the length of the rope, adjusting it for length. Two different types of eye here. This one here is simply a bent eye around, and it's not welded or closed up at that end. So this is a much weaker type of eye. This one is forged from an entire steel billet, or a chunk of steel, and so as a result it can't open up. So this is much better for this kind of operation. This is chain, which is made up of welded links of 1/4 inch diameter steel round bar. It's measured by taking a caliper and dimensioning the diameter of the chain, which is 0.249, so 1/4 inch diameter, and also the length of the pitch, which is the length of the inside of the chain, and that is 0.86, so that's 7/8, so it's 1/4 inch by 7/8. Knowing the diameter and the pitch, or the length of the chain link, is important because often it is used in mechanisms with sprockets that the chain wraps around for lifting or winching the chain up for things like anchoring in boats. Chain. This has a working load limit of about 1,600 pounds, so considerably stronger than wire rope, obviously. If you need to join sections of chain together, there are a number of ways of doing that. Probably one of the easiest is using a quick link like this, which is a section of steel that has a threaded nut that allows you to close it up on itself. We'd open it up fully and slip that into the length of chain there, and slip it onto the other length. And obviously it's important to thread this completely closed. And take a wrench and tighten that up. And that will create a closed link. The quick link does not have the same breaking strength or working load limit as the welded chain. So it's important to get the specifications on that before you put this into any kind of service. This is a much heavier duty chain. It's a 3/8 diameter link and an 1 1/8 pitch dimension, so it's much heavier than this other chain. These hooks on the end are permanently attached to the end of the chain with a forged split link that is wrapped around the chain, hammered in place, and then welded in 2 locations to permanently attach that, so that can't come undone. And it's much stronger than the quick link, but obviously we can't take it apart. The 2 hooks are used in different purposes. This allows you to hook the end around something else and remove it easily. This other hook is much narrower and has parallel jaws, and it's designed to actually hook around the chain itself to form a rigid connection which will stay in position as long as tension is kept on the chain. That can be easily removed and adjusted for length anywhere along the length of the chain. This is a fitting called a shackle, which allows us to loop this around a section of chain and lock that in place, or put it around a ring of some kind that might be attached to another structure and close that up. That allows this to move freely, and we can hook the chain onto either end of that, like so. Chain often gets a little bit dirty with surface rust and so on, and industrially it's normally oiled to avoid that, but you definitely get your hands dirty. A shackle, if it's sized correctly, can feed through something like this forged eye bolt and be closed up so that we can then attach something like a chain to that.